This is the Mars Inflatable Station, designed to be able to set itself up, and will be ready when human beings reach the surface of Mars. The station is composed of a main lounge and 6 outlying rooms in a hexagonal shape, joined by hallways with inflatable doors, with automatic valves to control air pressure inside. With this structure, we would have a lightweight, livable space station, which would make the mission of inhabiting Mars more viable. Keeping in mind its energy and structural parameters, it would be able to have its own hydroponic micro-ecosystem with the potential to produce food and oxygen, which in turn would give it a high level of autonomy. This project has been developed for the Mars Base Challenge contest from MakerBot in collaboration with the NASA Jet Propulsion Laboratory. The landing capsule replicates the one developed for the Mars Exploration Rover, containing in this case a vehicle for working. The closed, uninflated station will open in a random location, in which we don't know the surface conditions for the station's floor. After the capsule opens, the vehicle will start to clean the surface, so we will have less requirements for needing a strong floor for the base. Once completed, we have a leveled floor free from mineral particles, which could damage the station floor. Because the structural resistance would be created by pressurized air, the station occupants could walk on it. The work robot would be in charge of unpacking and extending this uninflated station, which once in place would be inflated with an air pump, installed in the vehicle or in the station, capturing CO2 from the Martian atmosphere to give it the required pressure. The doors would later be raised with the rest of the station. After being extended, the life module inside the station would start to inflate different rooms with oxygen brought in initially in bottles, preparing it for Earth-like atmospheric conditions. The pressure needed for sustaining life would raise the station's cover, whose density is calculated as more than 1 kilogram per square meter, while Kevlar wires placed inside the roof and walls would keep its shape. Separate from the rest of the station, a solar device would extend and connect itself. It would have a compact and light design and also be inflated with CO2, in turn getting the necessary energy for sustaining life on the station. Once finished, the station will be ready for the first astronauts reaching Mars's surface, who could live in it. We would be able to optimize habitability, finding a compromise between comfort and the project's budget. This would allow us to imagine a standing laboratory for 1 or more people, or a human colony in a not-too-distant future.